Very good morning on a Friday morning. I hope you are all healthy and doing well. So this is a tough time. So I pray for humanity that
Yes,
we
Wriju.
must.
Yeah. Very much. Very much. Yeah. Yeah. Yes, you are. Go ahead.
Thank you. So I pray for everyone. Stay healthy, right? Stay happy. It is tough time. So we need to stay together, right? Even if it is virtually, we need to stay together. So we have done it for last 1 year and we'll be doing it till the time this is resolved, right? So coming back to the technology, right? So today we're going to talk about various different things on Azure. So what I picked is something not completely related to Azure, but something which is cloud native and also works in Azure. So that gives a lot of a sense around what Microsoft is really thinking towards the whole ecosystem, right? So if you have observed over a period of time how we evolved and adopted a lot of open source technologies and then brought them into as a first class service within Azure, and that's what I'm going to talk about. So I'm going to talk about various different cloud native presence within our Azure landscape. And then I will definitely build an application as an application developer. That's what I do every day, right? So build an application and then show you the journey of moving it to that cloud native world in Azure space. But however, whatever I'm doing is it can be done in any other platform as well because it is independent of the provider, right? So that's what I have taken. So I have taken ASP.NET Core Web Application, which is again something which you can run in any platform, develop anywhere, and run and build and test anywhere you want to, right? So let's see a step by step. But before that, briefly, I work as a cloud solution architect in Microsoft, and this is my Twitter handle. So if you want to reach out to me, you can always reach out to me through the Twitter. I've been posting videos around Kubernetes because right now my current project and work evolves around working against that technology. So I did a lot of work recent time on that space. So I kind of thought of putting them together into a series of videos. I keep posting them in Twitter. So if you follow me, you will get to know that post happens every day, right? So that's the kind of thing. So let me jump into that. But before that, I just wanted to show you the steps I'm going to take, right? So I'm going to show you the development environment which I'm using, right? How to set up that. And then I will create a simple ASP.NET Core application and containerize that, and then push it to either Docker Hub or Azure Container Registry, which can be a private registry as well. And then I will host that container in Azure Container Instance. And I'll explain all of these technologies when I go into each of the steps. And then finally, we'll deploy it in Azure Kubernetes services, right? So that's the step I'm going to take. And before you join this session, I just wanted to show this slide that the first one is the code and scripts. So I kind of have documented everything and posted in GitHub. So if you want to try out what I'm trying out, because I will be skipping some of the steps like setting up the development environment, installing the runtime, installing the Azure Kubernetes services, because they take some time. And this session is only for about 1 hour. So I will skip those steps, but you can just refer this URL and get the script, run it on your own, and then do the same stuff. I even have videos around each of the steps. So what is the experience when you do that in the environment? So that videos are posted in this URL. So you can also view them directly from the GitHub page, which is the representation of the same GitHub repo on top. The second one is the GitHub page. One of the good things about the GitHub page is that I can embed the YouTube video. So you can see them in the page itself, not click on the link and then go into some other page, right? So you can have the embedded experience in the GitHub page. So that's when you have a 4-step video, which I have already recorded and then kind of posted so that you can experience the same thing. So that's the resource you might need if you are interested to really jump into that. So I do not have much slide, and this slide is also available in the GitHub repo. So you will you'll be able to see that thing over there. Now, I will jump into the demo screen where I'm going to basically show you everything, everything mostly in the command window. Now, before I go over here, I would like to show you the Azure portal where I'm working right now. So our resource group called RGGA 2021. That's the name of the resource group. And I've got few things already created. All right. The first set, which you get to see, right, from here to up to the third last one, are mainly for a virtual machine which I'm using. And that virtual machine is my development environment, right? Imagine today I'm using a laptop which is a corporate laptop and which does not allow me to install anything and everything. So I create a virtual machine in the cloud and then install the tools and runtimes I might need for my experiment or my work, right? So that's when I have created a Linux Ubuntu virtual machine, and then I have installed all the runtimes. So when you create a Ubuntu virtual machine in Azure, you basically get a full-fledged Ubuntu server, right? And then you can go ahead and install those runtimes. I have installed .NET Core, I have installed Azure CLI, I have installed kubectl. So 3 things mainly, but you can install many more things. And Ubuntu comes with Git component by default, so you don't need the Git. So I also need Git because I have been pushing it to the GitHub. Now that's the environment it looks like. And what I also have is my Visual Studio, right? So if I go ahead and then close this folder, so this is the Visual Studio code, right? That's a freely available tool to everybody. So you can just go ahead and download this 60 MB, 60. It's the smallest IDE you can ever think from Microsoft, right? And then you can actually use it for many different purposes. And what I am trying to do is that I'm trying to connect this Visual Studio code to my virtual machine, which is in the cloud. That's the beauty here. Now, before I do that, I want to show you what is there inside that virtual machine. So if I connect it, right? So what I have done here is that I have taken this, let's say, IP address from my virtual machine. So I created this virtual machine with a public IP address. So I've taken this IP address and then I did SSH. So let me do that again. Okay. So if I go over here and I say SSH and whatever the username you have mentioned, and then the IP address, it actually lets you into that virtual machine. So that's what I have done. So let me log in. Now, once your password is kind of correct, you are inside that virtual machine, and you can see that it talks about what is that, the version, etc. So it's the virtual machine I'm going to use, right? And just to show you that it has got all the components. So if I go into Git, so Git CLI is installed. If I say .NET, the .NET CLI is also installed. So you can see that .NET CLI, even if you can see what are the SDKs available. So if you say list SDKs, and you get to see the SDK 3.1. I explicitly installed 3.1 mainly because the 5 is yet to be adopted by many of the actual development, right? So I have seen so far, that's my experience, that 5 is not yet adopted heavily. Most of the development happens around 3.1. That's why I kept myself in 3.1. Otherwise, I'm an N+1 kind of person who always go after their beta technologies, right? So just for the sake of interest, I kept it in 3.1, but you can always use this demo in 5.0 as well. So I kept in the GitHub portal where I kind of kept the repository. I would like to also show you that experience. So that's the GitHub portal I was referring to, right? So this is the repository. And then you see that I have got scripts. So all the things. So how do you create the virtual machine in Azure, right? If you look into that script, and let me just increase the font size. If you look into that, I started with like, what is the password? How do you define the virtual machine password? And then what is the kind of like, how do you create a virtual machine, which is a cost-effective virtual machine? And after you create the virtual machine and log into that virtual machine, how do you install those tools and runtimes? So I have used Snap. Snap is one of the ways by which you can install a lot of software and runtime. For example, if you install Azure kubectl, you need to put that in path. You need to copy the folder in bin directory. All those activities, pre and post activities, will be done by the Snap. So Snap is a beautiful way to really install things in Linux world. I like that personally, but you can always use apt, right? That's the default Ubuntu installer. So then I have Docker also, right? So Docker CE, because I'll be building the Docker images from my development machine. So that's what I have all the scripts. So you can just copy paste and it will work exactly. I have tested it many times and it works. Right? So that's a kind of thing I have given. So I kind of created the variable. And if you go back into this and see, for example, the main page, if you happen to see over here, at this is a PPD slide, so you can always copy the slide. I also have YAML, which I'll be using little later. You have the sample code, which is nothing but the default sample. That's what I have in my source code available. Now, what I'm going to do is that I'm going to start building an application. Let's do that. So how that experience looks like. So I'm inside my dev machine. I have the .NET Core, and let's say I make a directory for today. That is April 16. Okay, and then I say cd. So I just created a folder called April 16, and that's where I'm inside. To create an ASP.NET application, you say .NET new, and if you want to create an MVC application, you say MVC, and then give a name. Now I say sample web. And what I'm also trying to do is that I'm not trying to configure a lot of complex stuff, so I remove the HTTPS thing. So I'll say no HTTPS. To do that, then it will be only running on port 80, because once you create the HTTPS kind of thing, it becomes a bit more additional tasks, which I wanted to avoid in the demo. So now my application is ready. Now it creates a folder called sample web inside that. So let me go into that. I go into that sample web, and you have all the files created over here. So you can see them over here. And just to check whether this is fine, you say .NET build. It'll restore and it'll run the build. That's just for checking purpose. I'm doing it. So my application code is ready. Imagine that you have got this code and now you need to containerize that. Now containerize that, you can do things in many different ways. Now, one of the things I can do is that I can have my Docker file and then have it here. Docker file is also available in my GitHub repo. So if you see that, if you go into the scripts folder, and then you have Docker file for 3.1 and 5.0. So I have got Docker file for both. So you can actually copy the content of the Docker file and create a Docker file over here. So you can take this content and just need to make sure that you provide the right folder, the project name, right? If you created a project called sample, you need to change this to sample DLL. Whatever the generated DLL looks like, that's the name you should be providing in the DLL. That's the only change you need to make if you don't put the name called sample web, right? So you copy the content of the Docker file, or you can generate the Docker file. So nobody today writes the Docker file from scratch. So they pick up the Docker file and then keep modifying it. We have a Visual Studio Code extension available called Docker extension. And if you use that extension, you can also generate the Docker file for any application. So let's try to do that. So if I say that I want to do a remote SSH, that means I want to connect to a virtual machine which is not here locally, right? So I say that I add a new SSH host, and that is SSH, and then whatever the IP address is. So let me copy the IP address and then paste it over here. And then it asks me where do I need to add, and I added it. It asked me to connect. Now notice here I am running Windows 10 machine while I'm showing you this presentation. I'm connecting to Ubuntu virtual machine, which is anywhere, right? Right now it is in Azure, but it could be anywhere. And if that allows my SSH connection from my local laptop, I should be able to connect my Visual Studio Code as well, right? So I'll say continue, and then it would ask me the password. Enter the password. I get inside the virtual machine, and if my everything, whatever I provided is right, you'll be able to see an SSH at the bottom of the screen, right? You can see that it shows the IP address. That means I'm now connected. Now, one of the things I wanted to also show you is that if I go into the terminal and say new terminal, you basically get the same terminal like an SSH terminal once you log in. So you can see the name of the machine, right? Just to show you that, if I say ls, you'll be able to see the April 16 folder here, right? It says cd April 16. You get inside that, you sample web, and everything looks exactly the same. So it is the same machine I'm connected to. Now what I can do, I can say open folder. If I do the open folder, what happens? I can just navigate to the local folder, go to the sample web, and say okay. Now this opens the .NET Core, ASP.NET Core application in my Visual Studio Code. That's what a developer wants, right? So let me also pass the password. If you use SSH key, this experience doesn't happen. But sometimes in the Visual Studio Code with password, because of the security reason, it might ask you again and again to enter the password. So you are inside, you can see that it can now navigate to all the files within that, right? I do not have a Docker file here. What I can do, I can just manually create a Docker file and then paste the content over here, right? That's also one way of doing it. Or else what you can do, you can use the extension feature of the Visual Studio Code. If you do that, you see that I have got few extensions. Now this is a machine where I have not used it. So let me check the Docker extension is installed or not. So it seems like it is installed, right? I also need to check if I have the C# extension installed, because this is what I'm doing. So C# is also installed. So you can see that I have got my necessary component installed. Now to add a Docker file, the first thing you need to do is that you need to add a task, right? What is the build task it would look like? That's what you need to tell the Visual Studio Code or your application repository. So Control-Shift-P is how you invoke the command palette. Now task, run build task. If you bring in the task, it will ask you a few questions, right? So there is no task. So yes, fine. Let's just have a file. And what is this? .NET Core, right? So it is, you need to tell what is the build task you are trying to build. And it basically produces a JSON file for you, which you can otherwise manually write as well, right? So it's done. Now, second thing I'm going to do is that I'm going to say Docker add Docker files to workspace. Now, if you do that, it asks you a few steps. It asks you what kind of application is that. You can see that you can basically work on any kind of application like Go, Python, Ruby, etc. So right now it is .NET Core, right? And then what is the operating system you want to target? Linux. And then what do you want to do? Say 80, right? You do that, and I say yes, it will produce the file, right? And I would like to show you how the outcome of the file looks like. So let us just wait for the whole process to finish. If everything looks fine, then it will produce the file. If it doesn't, then you just go ahead and replace it. Now you can either use this one, right? Or you can just use the Docker file which I have provided in my thing. This is a simple one, right? You can see there are only a few lines, but they mostly look the same, right? So you can just say that, let me remove this and copy. So you can see that it is kind of like a simple one. I just wanted to keep it simple because we're not going into the Docker file kind of session, but that's what we can use, right? So it basically takes the base image for .NET Core, builds a work directory, takes the project folder, restore the .NET, publish, that means it produces the DLL and then all necessary supporting files. Take that image. Each of the line is step. So you have got a few lines, right? So 13 minus 3, I think around 10 lines. So there will be 10 steps. So you can see that it basically builds that whole thing. So Docker file is available. Now, once you have the Docker file in your project folder, that where your CS proj is, you can simply run some command. Let us see how that command looks like. Now, let's use the Visual Studio Code to really run something, right? Or you can go into here because we can now increase the font size. So let's use this folder. If you say ls, you'll find the Docker file available, right? So this is the Docker file. And just to see if that is the Docker file we are talking about, you can just see the Docker file. This is how it looks like. You can see that Docker file having only 13 lines. That's absolutely fine at this point in time. So if I say quit, exit, now this is the Docker file. Now the important part, building the container, right? We have the source code, we have the Docker file. Now let's build a container. To build a container, you need to make sure you have the Docker running. So we have the Docker CLI. And if we say Docker PS, it should produce this kind of output. So let me run it again. If you say Docker PS, it should produce something. If you say Docker images, it should produce something like this. So you basically have the right, let's say, kind of thing available, right? So you can see that I've got few things already available. Now, ideally, in your environment, if you do it for the first time, you might not have those images, right? So you can actually delete them and then start from scratch. So let me do a Docker RMI. So imagine that, let's run these images. And then if I say Docker RMI, it allows me to delete the images one by one by using image ID or the repository name. And then it is iterative task. So I can run something like loop, right? So let's say Docker images minus Q and then -4. So if there is any dependencies, it'll ignore that and it'll clear up all the Docker images. Just wanted to do that because you will have a different experience if you already have the base images available versus if you do not have any images. So right now, I do not have any images. That's why I kind of cleaned everything, right? Now let's run the Docker build. So if you say Docker build, okay, and this is the simplest Docker build command. What it essentially tells that you have got a Docker file within this folder because you're not explicitly mentioning the Docker file called Docker file, and then you have the CS proj. If you have those two things available, what it will do, it'll start downloading the base image and then compile your source code, put that source code into that base image, and then make a container image and keep it available in your local image repository in the local machine. Now you can see there are a lot of download happening, right? So the largest one is 124 MB, right? So you definitely need a good internet speed if you're doing it. So that's why it's always recommended that you should be downloading the base image beforehand so that you can just compile. So if you, let's say, compile it one more time, it'll not download the base image, right? Because base image is already available. And I'll show you the Docker images folder, how it looks like. So let me quickly, while it is doing this, let me quickly go here and I say Docker images, the same machine, but two different things. You can see that it downloaded the base image and it is doing something with my own image. So because I have not mentioned anything, so there is none. So we'll take care of that part a little later. So you still have few steps left. I told you that each line is a step. So you can see 8 out of 10, 9 out of 10, 10 out of 10. And then it is successfully built. That means now my Docker image is kind of created, right? Very fine. Now, if I say Docker images, you get 2 images, right? 4 of them because you have got SDK and ASP.NET. These are all base images. And something happened over here. I don't know what exactly they are because I did not identify them properly. Now, to identify them properly, you can also use something like -t. And I say Wriju test. That's the name of the image, right? Now, if you do that, what happens? You can see that it is quite faster because it does not do the downloading of the base image, etc. It does create that. So you can see that it now tags my image as latest and then gives the name called Wriju test. Now, what happens when you have this kind of thing, right? And you basically build the Docker image already, right? You can try running that and to check locally if that application is working fine or not, right? So what I have done, I have built an image. That image is locally available, and then I want to, let's say, see if I can run that image. So to do that, let me remember that Wriju/test latest. Okay. So to do that, you can do something like this. So you can say Docker run, and then I just open the interactive terminal so that I want to see when you run an ASP.NET application, right? It shows you something in the command prompt. So I want to see that. So if you say run IT, and then I use something called RM. And with RM, it means that it will not keep any unused container in your local machine. So if you, let's say, a container is exited, then it will have a footprint. If you use RM, it will be deleted automatically. Otherwise, you have to go back and manually delete them. As I deleted the images, like that, you have the container, you have to manually delete them as well if you keep working on container, and sometime it will eat all your machine space, which I use RM for the temporary, because I'm using it for temporary purpose, just to check if my Docker container is working. So I have got a port 500 mapped to port 80, right? And I say I name it as sample underscore web. So you can give a name or you can skip it. So these are all optional parameters. So what I'm trying to do is that I'm trying to run at the container, and then the container name, that is Wriju test from my local machine, and I say latest. I do that, and if everything's fine, you can see that it shows you the prompt. It is exactly when you run the ASP.NET code in your local machine, right? You say .NET run, you get to see the same prompt. This ensures that my application is running. I can also do a port mapping and then open it in my local browser and then see the application. That can also be done, right? That is possible. I'm not going into that one because we are not doing a lot of ASP.NET specific activity, but this essentially ensures my app Docker is kind of running, right? So the container which I have created is perfectly fine. Now let's see how we can move it to a registry, right? That's the next step. So let me close this out and then clear this up. Now, what I wanted to show you over here is a few things. In the browser, if I say docker.io, that's a Docker hub. If I log in, you can log in also. It's a free for everybody. So you can even go here and create a repository by yourself. You have an you can have one private repository, and rest all will be public if you go with a free account. You can also create a new, let's say, image. So let's say I want to create something called April, get a repository, April 16. Okay, if I do that, this is demo on April 16. Okay, and then you can see that I am allowed to only have one private, which I already have created. And then if you say create, and that's going to go ahead and create that. Now what happens, your image should look like this. Now that's the main key aspect here, right? So whatever the name of your thing is, like in the Docker, whatever the username you provide, it creates the repository. And then the repository is April 16. You can version it v1, v2, v3. So let's do that over here. So you remember that I you added something called a tag, right? So instead of this, which is a local, very local to it, I can say v1, and that basically creates a new image. And you'll see here Docker images. Let me run it on top. Docker images shows me that April 16, right? Now this is the image which I'm going to use, right? And you can see that it's v1, and you know that the sample web is the default, whatever it is. I don't know how it looks like, but it is v1. So let's use this, right? And then move it to, let's say, in Docker Hub. And to move it to Docker Hub, right? First thing you need is a Docker login. From your CLI or wherever you are working on, you need to give the login credential. Docker login can have URL of your server, username, right? And then password. And if you do that, it basically keeps the kind of cache in your local this thing. So if you say Docker login, just Docker login, don't remember the whole thing, and then you can see that it is now connected. It says it is connected, right? Which means that I have done the connection already. So it did not prompt me. But if you have not done it, it will prompt you to enter the username. By default, it goes into Docker Hub. Okay, always goes into Docker Hub. And then it provides you, ask you for the username. So you give the username and a password and you are in. If you want to log into another registry, right, which supports Docker runtime, you can give the URL as part of the Docker login command. So you have to say that Docker login URL. That's what I'm going to do when I work with Azure Container Registry, right? So that's where you will be giving the URL, right? So we are fine at this point in time. Now, what I need is that I need Docker push. So I do that, and then I give the image name which I have created, this v1. You need to make sure that you also provide the tag. It pushes the image into my Docker Hub, right? You can see that something is happening. Now, what happened here over a period of time is that this ensures that it is kind of done. I go back to my Docker Hub, and then right now you can see that it is tags and scans are empty. If I refresh this page, it would show you tags and things, scans will have some information about v1. Now, the v1 is being pushed. Now you can see that this is what happened, right? And this is how it looks like. And you can check all the thing, blah, blah, blah. So you basically have all the information about this repository. Now we are kind of ready. Now we can also use this, right, to do a Docker pull, right? And then build a Docker container just like I ran the Docker run command. So if you are running a Docker run command again, instead of using the local image thing, you can give this name and it will be pulling from the Docker Hub. If you run this now at your machine, if you're trying it out, you can even use this, right? And it will run exactly the same way. So let me show you the Docker run command, how it might look like if you use this, right? So if you use this now, instead of this latest, you just need to change the name of the image, v1. And that's all. Now, if I do run this, it will not download because I am using the local image, and that local image is being pushed. So Docker is very effective in terms of using bandwidth. So if it finds the similar layers available already locally, it doesn't bring the layer from outside, even if the image names are different, right? So that's the beauty of Docker. It is very, very efficient, very, very bandwidth efficient, right? So you can see that if you run this command, right? I just want to, let's say, copy the content if I can copy it, and let's say keep it somewhere for you. If you want to run it, it will work. Today, it will work exactly the way it works for me. So it now using this sample, this URL, right? What I can do, I can run this in another registry. I can push it to another registry or run it. Or I can use this to populate, let's say, a container in some other container platform. Now, to run a container, you need to run them in a very enterprise way. That means make sure the servers on top of which containers are running up, the network is up, the power backup is available, there is no downtime and all these things. So it's a headache. Anytime you have got a live server working, it's a headache. Now, if you want to go as a service and run them like a container service, forget about Kubernetes, but just a simple container, hosting a simple container, you won't need to really know about the container runtime and configure them. You can use a service in Azure called Azure Container Instance. So let's see how that looks like. If you go into this resource group, now let me also use some UI aspect of it, right? I can also do it quickly using Azure CLI. right? So if I say container instance, yeah, if I create a container instance, now what happens? It hosts container for me, but I don't need to really worry about the infrastructure. Now the name of the container, I can say April 16 web. Okay, that's the name of the container. And wherever it is, that's fine. And then image is something like this. Why it is not allowing me to do that? Let me just check that. Yeah, DNS name. So you can give a DNS name to ensure that you are publicly accessible. So you can say Contoso 324, and then it becomes a public endpoint. And then if you have, let's say, a port mapping, for me, it was 500, 5080, and all those kind of port mapping you can do. You can say next, and then it basically tags and does everything, right? So that's the experience working from URL. I'm not very comfortable working on that kind of thing. So let me just remove it and show you a script which is already there in the GitHub. So if you go to the GitHub page and you go to the ACI script, which has got only 2 lines, you can actually use that ACI to copy the content. So let me do that. And let me copy that. Now what happens here, I'm going to create ACI, give a name, right? So I just gave some 2, 3, 4. Okay. And then I just need to make sure that your DNS is unique. Now what I need a change, small change, is the name of the image, right? So the name of the image is not this one. The name of the image is something else, which I kind of copied. This is the name of the image. So let me paste it. Now you can see that what I'm trying to do is that I'm trying to build a container with some name, and then inside a resource group, give an image for a port 80, DNS name is this. Should be fine. Okay. If I run it, it's basically gonna take few minutes and then spin up ACI instance within that same thing, right? Sorry, we are inside. We will be doing it from outside. Okay, so this is Azure CLI instance. Container instance. Okay, so let me just handwrite that. Ports 80, and then I say DNS -name label is Contoso 2345. Will it accept? Sure. Now what I'm essentially trying to do, what I have done locally, is I have tried to run it locally and then it worked. I essentially want to run it outside so that you have a public IP address and then public URL so that you can view it in the browser and see actual application working. That's the whole purpose here, right? So it will take few moments, and once it is done, so it accepted my request, which means it will work. Now, if the moment it is done, you will be able to see a new component called WGACI, whatever name I have given. That ACI, that Azure Container Instance, is available. And if you click on that, it will show you the URL because I have given a DNS, right, suffix, prefix, right? And then it will create a DNS, and then that DNS will be the URL for your application, because that's how the application will work, that ASP.NET application. So you can see that it is running. While it is running, right, we will not spend a lot of time waiting for here. I will come back once it is done. We want to go to another view. So what I am going to do is that now I have an image ready. It is in the registry, and I can push it to my AKS. If I, let's say, think from that perspective, and I can, let's say, try to build an Azure Kubernetes cluster, it will take some time. So what I have done is that I have already created the Kubernetes cluster. And again, the script is available. How do you create the Kubernetes cluster? Fairly simple, a very simple script, one single liner, and it'll create the cluster. So this is a 2-node cluster. And once this cluster is created, if you go into the connect, it gives you the command how to connect. So first thing you need to do is that you need to bring that Kubernetes config into your local machine. So let me show you that if I am right now. And what I am using is an alias. So if I say alias, kubectl, it basically allows me to type K, and that identifies as kubectl. So I don't have to type a whole lot of letters. So I can say K get nodes just to check if it is connected. That means it is connected. Now K get a config view will show you what is the config we have. So there are a lot of configs I have got. You can see that I have connected to many. Right now, I am connected to the AKS cluster in Azure, so which is WG AKS 2, right? That's the default context. Current context is the default context. You can see that current context is the default context, and it gives me the server details and the certificates, etc. And you can see that that's why I'm able to read the nodes, right? Right now, we do not have anything. So if I say K get all, it shows nothing because I do not have any Kubernetes object at this point in time. Now, what I wanted to do is that I wanted to start with, let's say, a basic Kubernetes deployment. So what I am going to do essentially, I'm going to create a deployment from an image, which is a standard image, right? Later on, bring in my own image. So if I do that, K get K create, that means I'm going to create a kubectl create and deployment. I prefer deployment over pod because deployment is auto managed. So it manages the pod by default. So if the pod goes down, deployment will ensure the pod is up and running. So it's easy. I don't have to really worry or break my head too much on the pod. So deployment, I create a deployment, give a name, and then say image, and I can use nginx if I do that. Okay, and then I say replicas equal to 2. So there'll be 2 copies of my deployment created. That should be fine. Image. Is created, done. Now you can see that the deployment is created. It's fast. So K get deploy. I'll get to see the deployment. We have to. So it's available, which means it's running. If I say K get pod, you'll see all the pods running. So they are auto-generated by deployment, right? So if you kill one pod, it will be automatically one will be available for you. So that's how the experience looks like. Now, let me do a side-by-side thing, because then you will be able to actually see what is happening over here. Now, if I just, let's say, refresh this. Okay, so I wanted to open the Kubernetes dashboard because then I will be able to visually see what exactly is happening. So let me copy this and let me go over here. It is done. So I'll come back a little later. So let me run this. And it's going to show up the Kubernetes dashboard in my local browser. Okay, that comes from Kubernetes. And that shows it asked me for a login. So let me provide the config file, which you basically download when you get the credentials. And it shows you the visual representation of what is happening in your Kubernetes cluster, right? That's easy for me to explain and then refer to. Now, what I have done is that I have created a new deployment called where. This is what it is. And then I have got 2 instances of that deployment. Hence, there are 2 pods. So I don't have to do a K get all the time, right? Kubectl get. And then I do not have a service. Now, this is running locally. You can go to local and then interact with it. But if you have to, let's say, interact with it from a public endpoint perspective, how do you do that? you need a service. And to create a service, you say k create SVC. That's a short form of the service. And then against the deployment called web, okay. And then I use another information over here while I create the service is that I want to say what is the kind of, let's say, port I want to open, right? So that's what I need to say. So I need to say port equals to 80, okay? And then there are a couple of types of services. One is cluster IP, node port. They are only for local thing, right? So if you have a API to API interaction internally within Kubernetes, you use those services. But if you have to expose the IP address outside and then use it, generally the web interfaces or the public facing APIs, you need this load balancer. It is only available in the cloud world, right? So if you use on-premises one, you don't find the load balancer. So I have to create a service called like that. Why there is a problem? Deploy, create SVC. Sorry. We don't create SVC, we say expose. Okay. So now this is gonna create a service basically. Now this, if you see here in my dashboard below, you'll find a service getting created. This is the second service which got created. First, it was Kubernetes, the default one, and it has got a public IP address. You notice here, and to know the public IP address. So if you say k get SVC, it basically shows you the public IP address here as well. So if you copy this public IP address and try to run it, and then I just open it in a smaller window because not much to show in this portal at this point in time. If you notice here, once this is warmed up, right, and then ready, it'll start serving the landing page of nginx, right? So the nginx landing page will be visible to you, right? So you can see that welcome to nginx from the IP address. If you can use the same IP address at your side, and you will get to see the same thing. So I'm not hiding anything. It's not magic here. It's happening live. So you can have the IP address typed in your browser, and you'll be able to see that. Now, next thing I'm going to do is that I'm going to replace this nginx image with my image, right? So let's do that. So this is the name of the image, right? Remember, we pushed it to the GitHub, right? So we can use this image, and I say that Kubernetes allows you to edit an existing thing. So I can say k edit deploy web. If you do that, it opens in an editor. So depending on whichever platform you are using, the editor pops up. So the thing I need to change is image. So if you see at the bottom of my screen, right, so the nginx image is kind of highlighted. That's what I searched. And if I say it basically allows me to do this. And then I can provide this image reference, which basically is pointing to my own ASP.NET application, if everything is fine. Okay, there's always if but. It is edited. Now you can see that it immediately reflects in the dashboard, and it started recreating the pod. I don't have to do that. Deployment will take care because they saw a change and they recreated the pod. Once both the pods are up and running, right, you will be able to browse to this IP address, and it should ideally be showing my page. Now, if I refresh this, it will see my ASP.NET, which I created. Now, you haven't seen this ASP.NET so far because I have never opened it in browser. But just to have that same experience, if you go back into, let's say, here, and then I say I want to go to the index, and let's say welcome, let's say Azure Global, Azure 2021 India. If I change this, simple change, save it, go under this, okay, and then I do a Docker build, which I did it earlier, right? And then not here. Let me delete this. And then I change it to V2. Okay, that's a version 2. So which means that I'm building this image with a new tag, with the new latest changes, right? So the V2 is I have given, and the V2 is kind of now deployed. And then I go into, let's say, this one, where I push this. So now to push this, I can use the same command. And what I can do over here, I can say push. If you happen to push that new image, you can see that the layer already exists, says that the base image is everything, only the change will go. So it's only delta, small thing. So that's gone, already up. Now, if I come back to my view where I was showing you the Kubernetes dashboard, I edit again. I edit the deployment. I change the image. And then I go into the end of it and make it a V2. Okay, that's the thing I do. And then I come out and the deployment is accepted. Do you see the pods are recreated, right? You can see the replacement. It's a rolling update happening, right? They have already the old pod, 3 pods. Now there'll be always 2 pods because once this third pod is ready, one of the pods will delete it. So they don't delete the older one immediately because by default, the deployment is a rolling update. If you choose the in-place update, then it will replace everything, right? So it's the strategy you take based on what is the need. If it is a breaking change and you don't want people to use those previous version, you go ahead with the in-place update. But rolling update is something which is accepted, right? So you can see that it is kind of now being replaced. Now you can see that under images, it still holds nginx, right? There is one pod which is holding nginx, and it will be replaced. Once this kind of is done, it will be replaced, right? So you can just now go to the same page where the welcome was showing and refresh it, same IP address, nothing changes. It changes the context, right? You can see that the title has been changed to whatever I made that change, right? So it is now reflecting. Now, this is not a DevOps thing. So we only have 6 minutes left. So what I wanted to do is that I wanted to really talk briefly about the DevOps. So what I have done for you guys is that I created a GitHub action. Now, if you notice here, in this, I've got some code written already, right? So which is a GitHub action. And that's a step-by-step kind of thing where it shows me what I am trying to do. So what I'm basically trying to do is that trying to make some changes, push it to the repository, making those changes back into the system, and then doing all those stuff. So the moment I make any changes to my source code in a Git kind of scenario, and then do a check-in, it triggers because it takes like my push, right? Whenever I push, if I have a pull request kind of environment, I can always have a pull request, merge request to the master if those kind of events I'm tracking, and I can do all the activity which I've done manually by typing individual command can be automated in a GitHub action kind of scenario. And I have documented that in my page. So you can go to the main page, you find a GitHub/workflows, and you'll find the whole YAML available, which can actually do the whole stuff I'm doing, right? So it basically pushes into a registry. So you can change the registry. So I'm using secrets. So how do you use the secret? In user mode, right? When you are logged in, you get to see the secret. So you basically have the secrets here, and you can just replace the secret with your own values, right? Give the same name and then replace them with your own values. You will be fine, and you can run the same command, right? You won't be able to use my secrets because they are in my GitHub repo, but they're not visible. That's what GitHub suggests. Also, you should not be providing any sensitive information just like a plain text because it's visible to everybody. You should be providing through secrets. So secrets is only available to me. When I log in, I get to see them. Now, it is basically deploying it also to AKS. You can see that it is taking the images from a registry and then creating the deployment using the deployment YAML file, which is available in the YAML folder. So this can be automated. I have tested it. You can see that I have run it for multiple times just to test it, and it got successfully deployed. Now, if I go into the one of the latest run, right, this is a historical run. It uses the Docker Ubuntu machine, which is the runner, we call it, right? So Docker has a hosted runner. So it gets into the runner. It goes to checks out the code and builds the Docker image. You can see that whole command is getting documented, right? So it's getting documented, all the steps and everything you can see that getting documented. And then finally, it will basically be deploying it to the AKS cluster, which is in my Azure, and it's the outcome of that AKS cluster deployment. Once the deployment is over, it'll show you all the output. So this is exactly what is happening. So every time you do either a check-in or you do, let's say, a pull request, you can trigger this process and this will do the same stuff which I have done. So that's the journey of moving an ASP.NET Core application. It could be Node, it could be Go, it could be anything, to a Docker container, putting into a public registry, either a Docker Hub or Azure Container Registry, and then using that public registry to build and run pods, which internally runs container within Azure Kubernetes service or any Kubernetes service. So if you have on-premises Kubernetes, you can also run the same Kubernetes command which I ran to basically deploy the thing, and then you will have this public website running from Kubernetes service, and then you can see the IP address, right? It's a public IP address and it's accessible to everybody. So with this, I want to end here.